These unusual images of sperm whales were produced by scientists. Hence the black bar that acts as a guide, and the little dots that appear on the whales. They indicate the source of the strange noises, or clicks, produced by these animals. They emit these sounds to orient themselves, communicate, and hunt. A single sperm whale ingests around 400 kilograms of prey per day. They are the biggest marine hunters at the very top of the food chain. They're also very mysterious, living most of their lives in total darkness at depths below 1,000 meters.
Les super prédateurs des océans sont les cétacés. C'est le cachalot, c'est aussi la baleine.
Cetaceans are the ocean's super predators. You have the sperm whale, blue whale, and dozens of other species. But we don't know enough to explain their role within the food chain, how they regulate it, or even how climate change will affect them. This species lives in total darkness, so it can be better studied using sound. The best method for observing these animals is to listen to them and develop instruments and algorithms to record and understand the sounds they make.
We're at the Information Systems Laboratory at the University of Toulon. A one-of-a-kind device has been developed here. It is built around a sound card named Jason, which makes it possible to observe marine wildlife using a set of microphones.
This sound card can record 5 audio channels simultaneously at a very high frequency, while using very little energy. It was quite difficult to develop because we had to combine performance and autonomy, 2 things that usually don't go well together. The idea here is to place the system in underwater tubes in a watertight enclosure. Everything has to work for 10 days to a month, and this is why the system can't be too energy hungry.
In the port of Toulon, Jason will be put to the test. Today, it's being installed aboard Sperm, an autonomous ship. It's the largest of its kind in the world. It has been equipped with 5 hydrophones, microphones that work in water, all linked to Jason's 5-way recorder. Sperm will drift for days, listening to sperm whales and following their movements, from the surface all the way to the abyss. In order to find their way in the dark, sperm whales see using sound, detecting the surrounding elements through sonar. More precisely, the clicks that they emit and the echoes made by walls and prey enable them to clearly perceive their environment.
Sound propagates remarkably well in water, much farther than through air, while retaining most of its qualities. Animals, let's say marine mammals, have used this property for millennia and have evolved to become specialists in submarine acoustics.
The scientific mission today is focusing on bioacoustics, the discipline that analyzes sounds emitted by living things.
We hear them, we hear them. Let's keep going. With this analysis, we're looking to understand individual animals, their size, age, and behaviors. We want to know if they emit sounds that reflect social behaviors, or if they're making sounds suited to locating prey. These signals contain a lot of information about the objectives and strategies of these animals as they explore their environment, and can even give clues about their intelligence.
The Jason sound card installed on Sperm is a veritable acoustic camera. It enables scientists to precisely locate sperm whales within a range of 5 kilometers. But in order to trace the movements of these animals in 3 dimensions, we must return to solid ground and the laboratory which can crunch the data.
The amplitude of the clicks is drowned out in the rest of the signal. And so the first challenge in isolating the clicks from the signal is to remove all of the background noise. Once we've located all the clicks, We can calculate their location spatially relative to Sphyrna.
On va essayer de les localiser spatialement par rapport au Sphyrna.
Thanks to a triangulation method using the 5 hydrophones, the team can retrace the exact trajectory of the animal in order to study its behavior.
Here we have the sperm whale that spent 3 hours diving. It made different dives that each lasted about 40 minutes. Its first dive went close to 1,500 meters deep. It came back up and then did that again 3 times along the canyon to optimize its hunt for prey. One of the objectives of this study was to see if there was a link between the clicks we receive and the trajectory of the animal. In other words, when it stops clicking, does it move more or less quickly?
The different trajectories were reconstructed. Each point here corresponds to a click emitted by the sperm whale. This model enables the precise measurement of the movements of superpredators, which hunt near the coasts, and notably to see how they adapt to human activity.
We have to understand that the noises created by humans mask environmental sounds, effectively rendering cetaceans blind. It's like being blinded by flashes of light, because they must be able to hear in order to see their environment. The more fairies and other disturbances like them, the less these animals can thrive, and so either they'll have to leave these waters, or there simply won't be room for them to survive.
This new method of bioacoustic analysis opens the door to a deep behavioral study of these mysterious sperm whales. Understanding their hunting techniques or reproductive strategies might better enable a harmonious coexistence between humans and these massive marine mammals.